Thanks for the kind introduction. Hello everyone, my name is Zhenghao Wu. I'm currently a PhD candidate from Peking University in China. Today I will introduce a testing framework for blockchain-based DApp, Kaya. In recent years, many blockchain platforms have been developed. These blockchain platforms all support smart contracts, which leads to a rapid growth of DApps. DApps have been widely adopted in many fields, including social, exchange, game, wallet, gambling, finance, and marketplace. A DApp is an application which uses web pages as the front end and uses smart contracts as the back end. This also means DApp testing should involve not only the logic of smart contracts, but also the behaviors of users in the front end. However, recent popular smart contract development tools, such as Remix and Travel, cannot meet the demands. Through the investigation of the app ecosystems, we find three main challenges. The first challenge is the inherent complexity of the apps. It's necessary for test engineers to test all relevant aspects of the apps at the same time, including the front-end events and the back-end logic. This means testing the apps is more complex. The second challenge is the inconvenient pre-state setting. Blockchain is stateful. Different pre-state may lead to different execution results. If test engineers want to achieve the state N, they have to redeploy the smart contract and replay all previous states. It's inconvenient for test engineers that they cannot achieve the state N directly. The third challenge is the requirements to understand logs. The variables in logs are displayed as addresses rather than readable names. The taken operations are also shown in a format similar to assembly code. Faced with these three challenges, we proposed a testing framework, Kaya. Kaya is composed of three modules, Kaya GUI, Core Function Module, and Log Analyzer. Kaya GUI accepts smart contracts and settings from test engineers and outputs test cases to Core Function Module. Core Function Module takes the responsibilities of executing test cases, including collecting useful information, transforming blockchain pre-state parameters, executing test cases, converting the output log into a readable format. Log Analyzer produces a report that test engineers can easily check. Now, let's follow a case to see how Kaya works. When using Kaya, we should indicate the smart contract that the app uses. Here, we input the smart contract of snail throne. Then, Kaya will extract the variables contained in the smart contract. Test engineers can also input the front-end events and set the blockchain pre-state. Then, Core Function Module will perform its operations. Finally, analysis reports with readable variables are output. According to the differences between original values and changed values, we can identify the logic of the app. We have designed the human study to evaluate whether Kaya is easier to use compared with Remix and Travel. According to the table, Kaya outperforms the other two tools on the whole. It also identifies that Kaya is easier to use. Apart from the table, we also count the average time spent by testers using tools to test some functions. Kaya is much easier to use for test engineers that it takes less time to complete the same testing tasks. Kaya can make test engineers write test cases conveniently, execute test cases automatically, which solves the challenge of inherent complexity of the apps. Provide a flexible and convenient way to set up pre-states, which solves the challenge of inconvenient pre-state setting. Generate readable analysis reports for easy comprehension, which solves the challenge of requirements to understanding logs. In the future, we will make Kaya support more blockchain platforms. And that will conclude my talk. Thank you.